Welcome friends to my YouTube channel. Now in today's lecture I shall going to discuss few numerical problems related to moment of inertia, that we have done previously. Based upon this we shall do few numericals. Okay, so let's start. Now the first numerical is that a disk of mass m is said to roll on a table. Okay, if r is the radius and omega is the angular velocity, then show that total energy is this 3 by 4 m r square omega square. Okay, this question is very important in exam, and sometimes in this question comes as a short question in examination. Okay, so just draw the diagram. That is, this is the disk that is set to roll on a table. Okay, now since the disk rolls down, so there is a translational motion obviously, and besides this translational motion the disk is rotating about its own axis. Okay, so there will be a rotational motion also. Okay, so say what will be the translational kinetic energy? The translational kinetic energy, if m is the mass of the disk and if v is the velocity, linear velocity, then this is the translational kinetic energy. And given that the radius of the disk is r and angular velocity is omega, that means we can put v equal to omega r. So this is the translational kinetic energy. Okay, and what would be the rotational kinetic energy? What would be the rotational kinetic energy? That is simply half I omega square. Okay, now what would be the moment of inertia of the disk about its own axis? That we know that the moment of inertia of a disk about its own axis is half mr square. Okay, so this is simply half mr square omega square. Okay, so this is simply 1 upon 4 mr square omega square. Okay, so what would be the total energy that we, what is the total energy? Okay, so what would be the total energy of the system? Just we have to add these two terms. Okay, so the total energy is what? That is E translational plus E rotational, that is half m r square omega square, and this is simply 1 by 4 m r square omega square. The result is 3 by 4 m r square omega square. Okay, so this is the result. So this is the required result. Okay, so this is our first numerical problem. Now the second numerical problem is that a spherical ball rolls on a table. Okay, find the ratio of translational to rotational kinetic energy. Okay, find the ratio of translational and rotational kinetic energies. Okay, so similarly this is the sphere, so it rolls on a table. So obviously there is a translational motion, and since it's rotate about its own axis, there is a rotational motion also. Okay, so what would be the translational kinetic energy? If m is the mass of the sphere and v is the velocity, then half m v square. Okay, now what would be the rotational kinetic energy? Say this is simply half I omega square. And previously we know that moment of inertia of a sphere about its own axis is 2 by 5 m r square, if r is the radius of the sphere. Okay, so just we put it, I is 2 by 5 m r square, and instead of omega we put v by r, that means v square by r square. So r square cancels, so this is 1 by 5 mv square. Okay, because here it is I omega square and we have to convert it in terms of mv square. Okay, so what would be the translational by rotational kinetic energy ratio? This is simply half mv square divided by 1/5 mv square. Okay, the answer is 5 by 2. So this is the required result. Okay, so this is our second numerical. So these are simple numericals, so you have to do these numericals in order to concept the clear. Okay, in order to clear your concept. Now the third numerical is that show that the kinetic energy of a rod of length L and mass per unit length m, this is given mass per unit length, okay, about an axis passing through the middle point, okay, and perpendicular to its length is, okay, L is the length of the rod and m is the mass per unit length. So we have to show, at first draw the diagram. So if this is the middle point, okay, this is the length of the rod, that means this is 0, this is L, so this is L by 2, this is L by 2. Okay, so we have to show that the kinetic energy is 1/24 m omega square L cube about an axis passing through the center of gravity and perpendicular to the length of the rod. Okay, now we all know that what would be the moment of inertia of a rod about an axis passing through the center of gravity and perpendicular to the length, that we all know, that is ml square by 12. Okay, m is the total mass and here is given m is the mass per unit length. So if L is the length and m is the mass per unit length, then we can substitute m as ml. Okay, so ml into L square by 12. So this is ml cube by 12. Instead of the total mass we put m into L, because m is mass per unit length and L is the length of the rod. Okay, so what will be the kinetic energy? Half I omega square. Just put this, half I means ml cube by 12 omega square. So the answer is 1/24 m omega square L cube. Okay, so this is the simple expression. Now next numerical, okay, that is today's last numerical, that say this is the, say this is a rod of length L and this is the center of gravity. Say this is 0 and L, so this is L by 2 and this is L by 2. So we have to find out the moment of inertia at a distance L by 4 from one end. That means at a distance L by 4 from one end. Say this distance is L by 4. So we have to find out the moment of inertia about this axis. Okay, say this is AB and say this is CD. Okay, fine. This is the center of gravity and the axis passes through it. That means this is L by 2 and this is also L by 2. Now we have to find out the moment of inertia at a distance L by 4 from one end. Say this is one end and we take an axis at a distance L by 4. So if this is L by 2 and this is L by 4, so what would be this distance? Simply L by 2 minus L by 4. That means L by 4. So this distance is L by 4. Okay, because this is L by 2 and this is L by 4. So this is L by 2, 4. So what would be the moment of inertia about AB? So we use the parallel axis theorem. Parallel axis theorem, that moment of inertia about an axis passing through the center of gravity plus mass of the rod into distance square, that means L by 4 square, this is equals to IAB. Okay, because moment of inertia about AB, this is equals to moment of inertia about CD, that passes through the center of gravity plus mass into distance square. So what would be my IAB? What is ICD? Now we all know that passing through the center, moment of inertia of a rod about an axis passing through the center is ml square by 12, and this is mass into distance square, the L by 4 whole square. So this is simply ml square by 12 plus ml square by 16. So this is 48, this is 7. So this is the result. Okay, so this is also an important question, that is we have to find out the moment of inertia at a distance L by 4 from one end. So this is the result. So if you don't subscribe my channel, then kindly subscribe it to get latest videos on physics. Okay, thank you.